So our speaker tonight is Morgan F. Smith. He's an UC Foundation Associate Professor of Anthropology at the University of Tennessee, Chattanooga, where he directs the Geoarchaeology and Submerged Landscapes Laboratory. He's a sixth-generation Floridian and grew up in Tallahassee, Florida. He received his PhD from Texas A&M University, where he studied in the Center for the Study of the First Americans. Thanks again, Morgan, for joining us. We'll let you take it away.
Awesome. Thanks for that introduction, Jamie. Let me see here. Okay, I'm gonna go ahead and share. Um, okay. We good on that end? Everybody can see this okay?
Yep.
Awesome. All right. Thanks so much for having me. I really appreciate the opportunity to get to talk to some fellow archaeologists and fellow Floridians about some of the findings from up in our neck of the woods, kind of in the Tallahassee area, and talk a little bit more broadly about submerged landscape studies in Florida and why they matter more generally. And I have co-author on here, Jesse Halligan. This is an adaptation of a talk that we gave for the World Archaeological Congress and Darwin, Australia, where we were both invited to represent Florida to talk about submerged landscapes more generally in the Americas. So I hear Jesse's talking or has already talked, but there's a couple of her slides in Paige Ladson on here. So how do you talk about underwater archaeology in Florida without talking about Paige Ladson? Just a couple quick terms. It's nice to be talking to a room of archaeologists, but I'm not going to assume that everybody focuses on the time period that we're focused on for the most part. So, you know, most of the research that has been done on submerged landscapes, though this is changing in the last couple of years, has focused on the terminal Pleistocene. So this is anytime from around 21,000 to 11,500 years ago. So this is the Paleo-Indian or Paleo-American time period, which ranges from who knows when to about 11,500. It seems that we're constantly pushing that date range back. But we kind of have a nice tidy end there at 11,500 at the close of the Younger Dryas. So speaking to a room full of Floridians is nice. Everybody's pretty intimately familiar with Florida being a carbonate rock dominated landscape. And most people, especially along the central Gulf Coast, are going to be pretty familiar with the fact that we have a super low gradient continental shelf. So these kinds of things combine to create an excellent preservation environment throughout Florida in terms of underwater archaeology. And one of the things that is a pretty common refrain in the line of work of some of these geoarchaeological assessments that we do is we're searching for when we look for these sites and we're looking for ones that can pass muster. We're looking for those that have unequivocal artifacts, secure geologic context, and absolute ages. And in Florida, artifacts really aren't the hard part of that equation. Most of us on here know that there are isolated projectile points that are just kind of in ambient in the river systems around here. So they're kind of all over the place. Unequivocal artifacts aren't the problem. The problem, typically, especially for the terminal Pleistocene time period, comes with the ages and the context. So Florida's environments are pretty punishing, especially after thousands of years in the ground. The acidic soils, the wet and dry cycles just wreak havoc on organic material. The place where this kind of torture of these sediments is somewhat abated is on these inundated landscapes where you have these sediment sequences that have built up that have been capped in an anaerobic environment, that are kept in kind of low oxygen environments. So these are the places that we can get nice stratified sequences. So not just meters deep sand deposits, actual layered facies. And in those is typically organic material for radiocarbon control, which is sorely lacking on the early end of the spectrum, particularly for Florida's cultural history. To that point, there are about 573 sites. If you take the Florida Master Site File, which taking it ad hoc is full of problems, you're assuming a lot of things. But if we just kind of take those assumptions in stride for a second, there are 573 sites recorded in the site file with artifact styles that date to older than 9,500 years ago. Obviously, we're dealing with a huge landscape loss, though. So on the right is a graded image of shorelines, by kind of defined cultural periods, all the way starting from 14 and a half to up to 8,000 years ago. So even 8,000 years ago, we're talking about a pretty tremendous amount of area that's been lost. Of those 573 sites with these old kinds of um, artifact styles, which are over here on the left, most people are probably familiar with Florida cultural sequence. We're particularly when we're talking about terminal Pleistocene stuff, Bolin and before. So actually, some of the earliest ages on the Bolin style in the southeast come from the Page Latson site in North Florida. But fewer than 30 of these sites have direct dates by radiocarbon. And most of these are underwater. So I'd say probably 26 of those 30 are underwater sites. And just zooming out a little bit to talk about the peopling of the Americas. This is a super contentious area where things tend to be changing by the moment. It seems like if I take a month off from reading the latest article, I'm behind. Um, but everything's pretty much boiled down to in common refrains at the moment to three options in terms of the peopling of the Americas. So the first is much before 20,000 years ago or post 15,000 years ago by the Bering land bridge. The second is after about 17,000 years ago by boat. These before and after timeframes are bracketed based on ages when this area was accessible. So when ice was not covering massive portions of this and when navigation was actually possible through a land bridge or by the coast. Um, and then perhaps a third option before 20,000 years ago by boat. And the question is, where does Florida fit in to this to the peopling of the Americas? And the short answer is that it really doesn't at the moment. So Florida is a really unique place. Um, and ever since scuba diving, which scuba diving for all intents and purposes recreationally was more or less invented in Florida, ever since people put on tanks and started going underwater, people started finding artifacts and faunal material and association. So here you have some images on the left of early divers in Wakulla Springs examining mastodon and mammoth teeth. The first systematic excavation of an underwater site in the Americas, probably the world, was done in Ocala, Florida in 1970, one by Charles Hoffman with the University of Florida at the time at the Guest Mammoth site. So there's this early record and there's this early relationship on Paleo-Indian sites and underwater sites. There's also these really well-established early archaic sites in the south, like Harney Flats is just also a Paleo-Indian base camp and an early archaic base camp. So it is a bit of a migration theory buster because as it stands, Florida is the oldest concrete site, Page Latson, which I'll talk about in a second here. That's the furthest removed from the entry point of any peopling of the Americas route. And this is really interesting. I think I was actually talking to my grandma several just last night actually, and she was talking about a Nova documentary that she had seen about the peopling of the Americas, and I was like, oh, well, did they mention Florida? And she's like, no, they didn't mention Page Latson at all. So, which I thought was kind of funny. And maybe it was just more focused on the entry routes as opposed to the problems. So it is, but in general, this is a bit of a migration theory buster that has to be contended with in some way or another. Because if people are in Florida, particularly at Page Latson 15,000 years ago, then that's not the earliest example, right? There are definitely older examples that we're missing. So we're talking about a minimum age of about 15,000 years ago. There's also really unique cultural traditions. I put unique in with a question mark here. Are these actually unique, or are these just things that we're missing elsewhere because we don't have the same level of preservation that we do on submerged sites? You all are probably familiar with these examples of ivory foreshafts that are typically made out of proboscidean ivory. So assuming that no post-depositional mining of ivory took place. These are made by Paleo-Indian people. There's a famous example from Sloth Hole that has this incision on it that represents an early aspect of portable art in the Americas. So all these things boil down to tell us that Florida is a really unique place to work, which most of us already knew. With regard to its place in the Southeast, there are depending on kind of how you identify things, 15 or so submerged prehistoric sites in the southeast that date before the early Archaic. So when we zoom into Florida, that number bumps up to about 63. Um, as you can see, most of these are clustered in certain areas of the state. So over there, 18 to 23, I saw Nancy White on here that she was just telling me about some really exciting stuff that they've been finding along the Chipola. So I probably need to update this map for Nancy. But those are over there. Then you have the Oscilla Wassissa cluster. They're dominating kind of in the center from sites 24 to 49. And then over there, we have some sites kind of more relevant to folks here in this meeting, as well as this group up here on the Santa Fe and Swanee River clusters, and a little bit further south, some new discoveries. Which Rachel was just mentioning that she's gotten the opportunity to dive out on the Manasota Key site, which is a newly identified site that fits into this kind of mortuary complex in the Middle Archaic in Florida. So, um, Florida certainly has more inundated prehistoric sites than anywhere in the Americas, probably the world. I've done as much research as I possibly can looking at documents in other languages about this, and I'm pretty confident in saying that. So we're going to be talking mostly about this cluster up here, the Wassissa Oscilla cluster of sites. And just to set a little bit of paleo-environmental context here, here we have some culture history periods on the left, and then relevant archaeological sites in the Oscilla and Wassissa over here, and their stratigraphic profiles. So in the Younger Dryas, we're talking about a period where sea level is rising somewhat rapidly, as well as before and after the Younger Dryas for the most part. And what's borne out, particularly in paleo-environmental assemblages, like over here on the right, just kind of pulling out the dominant features like pine and ragweed and grasses. What you can see is that overall during this period that's largely from 8,000 to 15,000 or so, there's overall a lack of stability in environment. So there are oscillations between pine and oak and ragweed and grass, and these things are kind of showing that this environment is in flux. And that's going to force whoever's living on the landscape at the time to adapt to those changes, particularly rising seas and changing ecosystems. So one of the first sites that I'll introduce is one that I've worked on pretty recently. It's called the Ryan Harley site. So this is located in the Wassissa River of North Florida. And this is a Swanee Point site. It's actually the only intact single component Swanee site currently recorded. So this is a culture that lives right in the smack of the Younger Dryas. This is among some of the most intense climatic change in North American human history. And when you look at Swanee Point distribution in the southeast, overall, these people are clearly adapted to the coastal plain, predominantly in northern Florida, down to about the Swanee River. Those Swanee Points do continue down into the central Gulf Coast area. We got that big number there. That's pretty much entirely Harney Flats. And Ryan Harley is really unique. It was excavated by BAR archaeologist Jim Dunbar and identified by Ryan and Harley Means, two river divers in North Florida who are ecologists and geologists. And what was really interesting about the site was not only were there intact Swanee points that were found from a single component layer, there was also microfauna and lots of other macrofauna indicating that was interpreted as a midden, so discarded food waste. Preservation was excellent. So there are intact, down here is an intact snake vertebrae that were found articulated on site. Microfauna like rodent and lizard and frog remains were identified. And also, kind of exciting, several stone beads were recovered from 16th-inch screen material from the site. So there's also some pretty exciting evidence of portable artwork there from Ryan Harley. So as I mentioned, it was originally identified by Jim Dunbar and Ryan and Harley Means down there in the left. So I went back to the site, and my colleague Jesse Halligan also went back to the site for reevaluations from 2019 to, or I'm sorry, from 2013 to about 2019. And what we did was the first thing we were trying to do was target this stratigraphic deposit. So we were able to use ground penetrating radar. You can kind of see in the upper left this guy in the kayak here is using GPR in the kayak to identify the artifact bearing deposit. So you can kind of see it's just this lazy little channel of the Wasissa River. Really nothing out of the ordinary about it whatsoever. You'd pass by it and never know what you're looking at. But beneath you here, there's some really interesting things going on. So so these profiles, the top are annotated, the bottom are unannotated. The Swanee Paleosol, the soil on which these people were living, is kind of highlighted here in red. So you can see under about a meter of sediments, dropping down to about a meter and a half as it's eroding out into the stream. This is how it was originally found, was it's actively eroding out into the river channel there. And beneath it are lots of dips and cross-bedded features, kind of indicating maybe a different depositional environment than what's above it, which looks pretty a lot more kind of layer cake stratigraphy that we're used to. So we keyed in on this and we were interested about it. But the point of this GPR survey was trying to get us a little bit more dialed in on where the Swanee Paleosol was, so that we could really target excavations. The next thing that we did was to try to understand the landscape of the site in greater detail. So we did a series of 700 and something, 780, I think, auger test pits across this landform. So here we have the map inset up there. We're in North Florida. This is the lower Wasissa River. So the upper portion of this river is a pretty standard anastomosing channel. And then it starts to braid into lots of low energy channels that move all the time, that are constantly kind of carving in and out. And Ryan Harley's located right here on one of these. So we put all these auger test pits in where we augered down to the Swanee landform. And we measured that depth for each auger hole, the surface of the Ryan Harley Swanee Paleosol. And we came up with a digital elevation model to basically show us what the landscape looked like. And what was really interesting is this is a pretty flat, featureless hydric swamp at the moment, right? So there's not a lot going on. But in the Paleo DEM, there's lots of microtopography. And you can actually see some of these features have these kind of arcing shapes. And what we determined through sedimentological data is that this is actually a dune field, analogous to a coppice dune field, which is like a shrubby dune feature. And behind a lot of these dunes are deflation hollows, which are little dips that occur on the backside of the dune field. And this is kind of an interesting um, exercise in geologic data, because when you look at it today, it's this lush riparian ecosystem. And then when you excavate down to the surface of the Swanee component, you're on the sugary white sand, and it has all the classic hallmarks of Aeolian wind deposition, so frosted grains and skewness and kurtosis towards the lighter grains. So this is the landscape that we're looking at, and it looks like the Swanee people lived on the backside of one of these dunes, perhaps as a windbreak, um, or something like this. Maybe one of these dips was a seasonal pond. We know that during the late Pleistocene, many of these rivers weren't flowing like they were today until maybe the mid-Holocene or even later. So water was scarcity on the landscape, and these dark blue areas are areas where seasonal water would be likely. So looking here, this is the sedimentological and soil characterization data from our primary sediment core of the site, the most representative sediment core. And down here is the Swanee component. This is Unit 3. And you can see there's a lot going on in total carbon and skewness and kurtosis and standard deviations of particularly sands and clays, and also silts. So these things are combining to show us that this is definitely some kind of soil. And the average grain size is not quite the coarse sand that we're used to, but something a little bit finer, indicating aeolian reworking, which fits with data that was originally proposed by Harley Means, who's the state geologist. Dating the Swanee component at Ryan Harley was super problematic. None of the bones, none of the faunal material, which was well preserved otherwise, had any collagen that was able to be dated, at least as of 3 years ago. Maybe in the future things will be datable. Above the Ryan Harley Swanee component is a sequence of peats that date all to the these are in radiocarbon. So these all date to the early Holocene, middle Holocene, and later. Um, and beneath the Ryan Harley Paleosol, which is again the sand, we were able to get some OSL ages on it. Um, and those came out to 50,000 to 57,000 years old. So what this is telling us is that this is a super old relic land surface that's probably analogous to these kind of shifting sands, coppice dune fields, where sediment's constantly moving about. It's a pretty sediment-starved landscape. There's no deposition occurring between 50,000 and 8,000 or 9,000 years ago. Which can typically be problematic for some archaeological sites, but fortunately, for whatever reason, Ryan Harley escaped, a lot of the ravages of time and escaped later occupation also because it just survived as this little single component site hanging out there for us. So hopefully, maybe in the future, we'll get some student can go back and find something and with better technology, maybe nail down some radiocarbon ages at the site. There is an amazing lithic toolkit, an awesome assemblage from Ryan Harley that's pretty classic Swanee. And what it allows us to do is, since we know it's a single component site, it's the first place where we can actually diagnose what the lithic toolkit of a Middle Paleo Indian assemblage looks like in the Southeast. So this is an uncommon thing because there is no other single component site, especially in Florida, of a Middle Paleo Indian assemblage, and they're rare in the Southeast in general. Um, so what we have here is an opportunity to see what Swanee point makers carried with them on the day-to-day basis. Um, Overall, the toolkit is kind of what you'd expect from a group living in flux. It's a pretty flexible and adaptive toolkit. So there's biface, which we were able to do use-ware on a subsample of this toolkit. So this is just a small assemblage selected. And overall, the bifaces, kind of the wear on them is super varied. Thus, the usage is pretty varied. It looks like they were used on both hard and soft kind of materials. There's a interesting assemblage of formal unifaces. Most of the wear there is bound to the edges and arises on the surface of the edges. And most of that is pretty pronounced polish, indicating work on harder materials over longer periods of time. There is an informal expedient toolkit assemblage also that overall just kind of has erratic use wear on them, indicating that they were just kind of used for made for a certain purpose and then discarded there on site. So overall, what that assemblage is telling us is that it looks like Ryan Harley was maybe some kind of base camp where people were gearing up, so to speak. So maybe there was a lithic raw material quarry nearby. Um, And overall, it looks like the items that were discarded were at the end of their use life. So they're heavily curated. They're really far worked down, indicating these people transported these great distances, which implies that they didn't know perhaps where their next raw material outcrop would be. So this kind of paints a picture of a group that is still maybe settling into the landscape, still trying to figure out where the resources are and where the stone tool is. So this kind of highlights the fact that these people are living maybe in some time period of environmental uncertainty. Just talking a little bit about Paige Ladson, which sets the stage for a lot of things. So the most interesting thing about Paige Ladson, the most renowned thing about Paige Ladson, is certainly the component, the basal component of the sinkhole that is 14,550 years old. So, brief introduction to Page Ladson. It's a sinkhole on the Alsilla River in North Florida. This component is why it's famous. There are 12 unambiguous artifacts there in Unit 3, which is the pre-Clovis component, including a biface found in C2, a worked flake, and several other flakes. Nothing is culturally diagnostic, but it's all intermingled in the in this archaeological unit with the remains of mastodon, camelid, bison, and other Pleistocene fauna. Um, Jesse Halligan has been leading excavations there since around 2013, and she's produced 200 plus new radiocarbon ages that add to the already pretty incredible data set that existed for Page Ladson, which was directed by Dr. Jim Webb or David Webb and Jim Dunbar and Michael Fott as part of the Osceola River Prehistory Project back in the 80s and 90s. Another interesting thing about the site is a potential butchering marks on a mastodon tusk. As I said, lots of new radiocarbon ages, so almost overkill on the amount of dates that have been pulled out of here. But this had to be done to demonstrate that the sediments were intact and were well stratified. So Jesse was definitely working in an uphill battle to demonstrate that these deposits are in fact remarkably intact. But I think something that's kind of overlooked oftentimes is Unit 5. So when we talk about Page Ladson, we talk about Unit 3 down there with all the mastodons and mammoths. But a really interesting thing comes from Unit 5, which is a late Paleogene, early Archaic component that's actually an incredible Bolin component. So some of the earliest radiocarbon ages on Bolin come from Page Ladson. Recent excavations at Page Ladson also produced a Swanee point in association with datable organic material. So these will be the first radiocarbon ages on the Swanee point style, which is super exciting because currently it's completely undated. So we're actually unsure of its ultimate place in the culture history of Florida. And what's really interesting about Page Ladson Unit 5 is that there are also features. So there are fire pits where there are concentrations of wood and charcoal and gastropods. And these features date to 11,500, 11,600 calendar. And they're incredibly well intact. The charcoal is really well preserved. And features in general are super uncommon on submerged landscapes. So it's pretty incredible to be excavating through some of these items that are of really great antiquity in places where people wouldn't really normally think that they're located. Another place that we've been working at recently that we've kind of tidied up shop at is called the Guest Mammoth site. So I introduced this briefly. This is down closer to this group in Ocala, the Silver Springs area. And the Guest Mammoth site was the first professionally excavated underwater landscape site in the Americas. And this was 1971 when it was excavated. It was published in 73, and it was largely written off. So most people didn't believe that it was an intact site. And in the 70s, that was finding a very early site in the Southeast went against established paradigms far more than it does today. But the site overall is in the Silver River. So it's in this kind of Central Valley physiographic feature of Ocala. So it would have been a pretty lush ecosystem bounded by uplands on either side. And I went back to it in 2018, 2017, and 2018. We conducted excavations there to reassess its integrity and its potential. I had read a lot about it, and I thought it seemed like a pretty open case to examine. What was presented was pretty compelling overall. So Charles Hoffman wrote a single paper on it in 1983. And this is an image from what I've been able to reconstruct of his work. There's very little material left overall. There are only a handful of bones left and some notes at the Smathers Library in UF, but none of the artifacts exist anymore, and the papers are a little bit scattered. But I was able to rebuild the Guest Mammoth bone bed. So he identified the remains of two, possibly three, mammoths at the site. And in association with those mammoths were microdebitage, several flakes, cut marked bones, and a biface down there at the bottom. The biface is missing. I wasn't able to relocate it. It's teeny tiny. That scale is in centimeters. So it is, I mean, it's 3 centimeters long by 1 wide. It's so tiny. It's really perplexing. And it does appear to be basally thinned or maybe an attempt at a flute. It's a really interesting, curious example. It was found in the os area, the hip joint of one of the mammoths. So this is a juvenile and a calf mammoth. And Hoffman indicates a third mammoth, but doesn't really explore more on that. And I think we kind of might know why. So we reinvestigated it, and it took a while to actually find the archaeological site. So after 50 years of river transport and erosion and forgotten memories, it was all but lost, really. So we went back with a couple locals who were able to narrow it down for us, and we actually ended up relying on the state of Florida underwater archaeology team. They brought out a magnetometer on a hunch that I had that archaeologists are pretty good at leaving stuff behind when we excavate a site. So I've lost many a pocket knife in Paige Ladson and Ryan Harley. So I figured something might be there. And sure enough, we found 2 hits on the magnetometer. So we were kind of doing the archaeology of archaeologists. And it ended up being a cluster of unit nails that was left behind that teed us right into the site. So what we were able to do is pretty much demonstrate a lot of Hoffman's original interpretation. So we found more proboscidean material, including down there B at the bottom of the profile. That's a tooth from a fetal mammoth. I think this is the third mammoth that Hoffman thinks he found. So it's possible that one of these mammoths was pregnant with a baby when it was dispatched. Perhaps that was why it was isolated and hunted in the first place. But you can see above that, this is kind of a similar case to Ryan Harley, where I have a really well stratified component down to the early Holocene. And then after that, not much material. These mammoths lie on a really tough indurated surface that seems to be the remnants of a Pleistocene pond that you can see is kind of starting to dip down there to the right side of the profile. We did manage to get an OSL age right at the base, directly underneath the tibia there. That's C, the mammoth tibia that we recovered, which came in right on the money at 12,700 plus or minus 1,035. So an age that lines up really well with the extinction and extirpation of megafauna in the southeast generally. We did find several lithic artifacts there on the right also, as well as microdebitage and what looks like maybe even a flake of mammoth bone. Um, so it was really exciting to go back to this site, and this site that had kind of been almost lost to time, and reestablish what Charles Hoffman already knew about the site, but actually be able to kind of justify some of his early thoughts on it being a significant locality. So some of the things that we're interested about more broadly in these kinds of studies is particularly looking at environmental stress and environmental change. And one of the looming questions is, like, was Paleoindian mobility overall forced by environmental stress, right? We think that, but getting concrete data to demonstrate that is actually really challenging. And I think an interesting study that came out about 5 years ago now that relates to this was in the Geological Society of America. And it was a modulated examination of the intertropical convergence zone, which we all know as Floridians is the area that hurricanes develop in. And actually, during the Younger Dryas, the intertropical convergence zone shifted quite a bit south, which would have sent hurricane trajectories to Florida directly far more frequently. So Florida would have been receiving far more storms during the Younger Dryas and of much higher intensity. So these data sets indicate that conditions were pretty ripe for multiple Category 5 storms to be making landfall on the Florida platform in a given year. And obviously, these are huge events. And anybody who's been through, any kind of hurricane understands the power that even a one can have or a two. Um, So it's really interesting that we're seeing people constantly moving up and down these drainage valleys. And we're starting to wonder whether or not there is some pattern to this where perhaps people are moving up into these drainages into highlands, in the late fall and winter when storms are hitting the coast. Because as storms are hitting the coast, they're also charging up this groundwater in these upper areas and these catchment areas of these riverheads. So while they may be dry during the summer, they would typically have seasonal water during these periods. And then during the summer, when water gets scarce in these drainages, they move back south down drainage out towards the coast, the resource rich coast. So this is an interesting thing that some of these sites that we're looking at are starting to point towards. In our area, we're also super fortunate to have an excellent data set offshore in the Gulf of Mexico. So my colleagues and I have been working out there for the last decade or so on a series of inundated landscape sites just south of Tallahassee in Appalachia Bay. And just to give you a sense of scale on the site here, so this the two boats in that image that are circled in that picture, those are our two research vessels, and there's FWC boat over there on the right. And that little light colored patch that the boat with the blue top is anchored over, that's the boundaries of the archaeological site that I'll be talking about that yielded over 3,000 lithic artifacts. It's a quarry site, a raw material reduction site. But every white patch in this image is also an archaeological site that has been completely unexamined so far. So there's a lifetime of work just in this image alone, and there are acres and acres and acres of this in Appalachia Bay. So, it's a pretty daunting task, and it's a pretty huge problem. The moment you go offshore and you look around and there's no land in sight, or it's very far off, the enormity of the challenge becomes really apparent. But this site that we've been working on called Quint Scallopole, which was reported to us by an amateur diver, actually an off-duty FWC officer who was scalloping, um, is really fascinating. So, first of all, it's in an area, it's not in a river valley. Most of the research that's been done offshore has focused on river valleys, particularly the Paleoocella drainage. So, as it extends out into the Gulf of Mexico, the same river that Paige Ladson's in, there are sinkholes offshore, all of which are artifact bearing. Of the 26 offshore sites in the Gulf of Mexico, I would just hazard a guess that 14 of them are in the Paleoocella drainage. So, what's interesting about Clint Scallopole is it is in between the St. Marks River and the Osceola River on a sediment-starved landscape that is basically scoured to bedrock. So when we think of continental shelf archaeological sites, it's easy to think that they're all chewed away and completely destroyed by sea level being analogous. I've heard this thrown around a lot that sea level is analogous to a bulldozer that's just coming up and just destroying everything as it makes its way up. And one thing that I think is definitely certain about offshore archaeology is we know way too little to make general assumptions about what's going on out there. And I think what's really interesting about Quint Scallopole is what you're looking at in this image is actually an NC2 flint knapping station. So all of those pieces refit in place back together. You can kind of see there's like a workshop here going on with this cobble. And if the site was in fact bulldozed and destroyed by sea level, this would not happen. We wouldn't have in situ refits on site. It's a raw material reduction site too, so it's a bedrock quarry of actually pretty high quality Swanee chert. So there's a student bagging a biface, a early stage biface from the site. And what's interesting about this, in terms of it being a quarry, is quarries are notoriously tricky on land because it's very difficult to nail down what time period they're from. Offshore, they're actually pretty useful because we know, assuming that indigenous people weren't diving to mine chert, that there's a terminus post quem age associated when sea level encroaches past. We now know that that resource is probably inaccessible. So we can actually have chronological placement on some of these. And it looks like Clint Scallopole was inundated maybe around 5 to 4,000 years ago. So around the Middle Archaic time period. Something that's pretty neat about this site is that there's actually preserved site distribution patterns. So up here in the northern part of the site, this kind of looks like Texas, weirdly enough. I'm just realizing this now. But up here in kind of this panhandle, northern part. There's a couple bedrock exposures. So those red pentagons, those are bedrock Swanee chert exposures. And you can pretty clearly see that there's a intensive core and tool concentration, you know, 5, 10 meters away from that area where people are removing the chert from those bedrock exposures and then working them pretty intensely in separate stations down in the south part of the site. So we actually still have preservation of site areas as well. And then last, we did kind of a little study in raw material size. So just size classes, looking at artifact transport, with the assumption being if site formation processes happen as we said they did, and they came up and kind of destroyed everything, we'd expect a lot more microdebitage in the northern part of the site than the southern portion of the site. That didn't bear out. So there's no statistically significant variation and stuff that would point towards major post-depositional disturbance, which is pretty interesting. Um, so overall, I think what we're getting at here is that site formation processes offshore are far more variable than we expect them to be. They can go through some of these things or none of these things, depending on how they're first buried and how they're first deposited. And then the last thing that I'll kind of leave you with is a study that several of my colleagues and I are also working on using kind of experimental acoustic methods to identify submerged archaeological sites remotely. So this was first identified by some colleagues in Europe in the early 2000s, and they identified that these patterns, which are down here, this is a sub-bottom profile image here, and you can kind of see these wavy patterns in the water column. They started seeing those being related to archaeological deposits pretty frequently. So they immediately came up with this hypothesis that you could maybe use low frequency sound, similar to how you use a tuning fork to tune a guitar. Use low frequency sound to structurally excite and generate a response out of stone tools underwater. So I got an NSF high risk research award to test this out in Appalachia Bay. And overall, we sampled 24 sites. We tried to sample every single site in the Gulf of Mexico. We didn't quite get all of them. But we looked at a pretty good sample. And though we had mixed results overall, most sites that from which we expected resonance and artifacts produced this signature. And I show it here. This is the Quint Scalpel site. So this bottom, this is another in situ flint knapping workshop there. And here's kind of a map of the sites that we were looking at. So this profile, you can kind of see this chatter in the water column, this noise. So that is the signature that we're thinking some of these artifacts can make when the correct frequency of sound is emanated and strikes the object. So we've done a lot of work to model this in the lab, and we have demonstrated the fundamental premise on the supercomputer at the University of Tennessee. So this is actually a time slice of the resonance of a lithic artifact happening in real time. So it was struck in this case, with an impact hammer, and it rings with a tone. So just like, again, back to the tuning fork exercise, and it emits sound waves. And those sound waves can interact with the sound waves emitted from geophysical instruments. And I know this is a little bit off the wall, but this is just kind of one of the ways that we're approaching this is looking at, doing lots of iterations of this in the lab so that we can kind of get to the bottom of what's actually happening here, so that maybe we can take advantage of this phenomenon to more readily identify sites offshore. So my students have been doing this with chert from Texas and receiving these kinds of responses here on the right. So each of those peaks is indicating that the artifact is resonating and that resonance can be measured. But the other problems that we've been running to is other things resonate, right? So the shell tools that are common in this region also resonate, as does fossilized bone and ivory. So this is essentially lithified material, fossilized bone and ivory. So you're going to get some of that also too. Coarse earthenware ceramics, not really, fortunately, maybe a little bit. Bottle glass, historic materials, definitely. So this is a really interesting phenomenon that we're exploring at the moment, that I think has a lot of promise to kind of move things forward and how we do this kind of work. Because in wrapping up here, one of the problems that we've seen is that identifying these sites out there is often analogous to a needle in a haystack, and it really is. So we've had conversations with law enforcement of FWC, marine biologists who are deploying artificial reefs, and they're unaware of these resources that are out there. Um, and the state that, coming up with new methodologies to find these kinds of sites on this frontier is super important because they are being lost. There is looting going on the continental shelf. And it's important that, while we have the upper hand, we kind of seize it here. And I think one of the biggest problems that we might be working on is that we commonly modeled what the landscape would have looked like and use that as a determining factor in how we find these sites. And we typically rely on side scan sonars and magnetometers to do this kind of work. And we know that these don't really find submerged landscape sites. They find shipwrecks quite well. And they do so in a way that makes it look like shipwrecks are far more common than submerged landscape sites, even though we know that that can't be the case. We know there must be thousands of these out there that have yet to be found. It's just a matter of how we find them. So at the moment, several of us are working with a cooperative agreement with the Bureau of Ocean Energy Management. This is directed by Jesse Halligan, so my co-author here at Texas A&M University, and colleagues from Florida State University, as well as at the Smithsonian and across the pond in Bradford, are working to re-evaluate how we find archaeological sites in the Gulf of Mexico more generally, um, with the idea of coming up with a new policy that dictates how sites are identified and studied and surveyed for. And a hallmark of this efforts is a tribal engagement aspect of our work, which few approaches so far have considered kind of from the beginning and at every level. So we're really excited to get this going through 2029. And I'll just leave you with, your region, the Central Gulf Coast region, is pretty much a blank space on the map. So if there's any interested students out there who are excited about this kind of work, the only name that really comes to mind in this huge, broad region is Matt Newton, who may have already spoken, to you guys, and he's doing some pretty pioneering work off the Swanee River Delta. And it's really challenging to be the first person out there, So I know he could use some help, and there's definitely some problems. There's always going to be challenges with this kind of work, but I think the potential is there, and it's a really exciting thing to see somebody getting after it. So thanks so much for time today. I do just want to make a quick shameless plug that if you're interested in this, the Center for the Study of the First Americans is putting on the Paleo-American Odyssey Conference 2.0, or I guess 3.0 really, in Santa Fe, New Mexico in October. There will be a lot of Florida Paleo-Indian material there. So if you're interested in this kind of work, come on out and see us there in Santa Fe. And that's going to be a People in the Americas Central conference. And my colleagues and I did just do a documentary for PBS with the WFSU station up in Tallahassee. That's about an hour long and goes through kind of the history of this discipline in Florida and some of the current findings. So if anybody's interested in the kind of a more popular item, there it is. But thanks so much for your time. Happy to answer any questions.
Thank you so much, Morgan. Very fascinating stuff. Incredible. Yeah, so we'll open it up to questions. If it's easier for you to type them in the chat, that'd be great. If you want to unmute yourself and ask the question, that works too. We'll figure it out.
I had a question that can get us started. So first of all, I put the link to this documentary in the chat if anyone is
Oh,
interested.
thanks.
Yeah. So Dr. Smith, you mentioned that this is an area that needs more study and that people could help. What should someone do if they are diving off the coast of Florida and they think they found a site?
Ooh, that's a great question. FPAN coming in hot. I like it. So obviously, if you're offshore, so I think if in saying this, there are 26 recorded sites in the Gulf of Mexico right now. Okay. So in Jefferson County alone in North Florida, which I'm really familiar with, there are 1,900, right? And there's a smaller area of the continental shelf out there than there is Jefferson County. So there are tons of sites out there. It's just a matter of looking. And I think, I encourage sport divers to responsibly go out there, and as they're recreating, be observant. That's how we found Quinnscalapole. Obviously, if you find a site, it is absolutely critical that you remove nothing from the site and you take a really accurate GPS coordinate, on your fish finder or your phone, whatever you have, and immediately get in touch with FPAN or the state of Florida and report it even if you're not sure. The data set is so small offshore at the moment, um, that everything is significant. Like I was saying, 28 sites, even if we had 28 more, we'd still be at a comically small amount of sites compared to other counties. And these sites are really skewed towards certain time periods and certain geographic areas. So I think, I'm always encouraging of responsible public avocational involvement. But yeah, absolutely, absolutely. If you think you found a site offshore, report it to the responsible people who would be FPAN in your area and in the state of Florida.
Excellent. And we have some questions in the chat. The first one's from Nancy White. She said,
Hey,
"Great
Nancy.
talks, or great talk. Thanks. When do you plan on getting the date for the Suwannee component, and where
Mm,
do you plan on publishing it?"
we have the date. That's a Jesse Halligan question because Jesse paid for the ages. So, but that I imagine will be published probably in the Paleo Odyssey volume. So we're putting together a big volume for that. So I definitely say, in the coming months there will be something being put together on that. But the date is there, and I'll say it's not surprising for me. So,
All right, thank you, Morgan. And then Krista Ledford's said she watched the PBS documentary and said it was fascinating. So
Awesome.
great.
I would encourage also everybody to, if you're a fan of PBS or public broadcasting, to support your local public broadcasting at the moment. I think it's that was kind of a fun one-off that we actually got supported on by the state of Florida, the Division of Historical Resources. We received one of their small matching grants to be able to do a documentary, because I just thought it was, you know, there's a lot of documentaries out there about shipwreck archaeology. There are none really about submerged landscapes. And Florida is so central to it. And I've been fortunate enough to have, a front seat to see a lot of this stuff. I'm from Tallahassee. I grew up 25, 30 minutes from Page Ladson. So it just felt like a really fun thing to do. And that's been a huge resource. A lot of people have reached out to me, who have enjoyed it and learned a lot. And public broadcasting at the moment is definitely under fire and under threat of reduction. And that would be quite a tragedy if we didn't have responsible, resources out there for the public. So definitely support PBS.
Yeah, absolutely. Do we have any more questions?
I totally have another question. If
Yeah,
have
get it.
you revisited or have you gotten any reports from the sites that you visited since, like, after really any hurricane? Like, I know you were saying how incredible it is that these sites are intact and that, for a long time everybody was like, oh, those, if it's underwater, there's no context, which, has
Mhm.
been proven to not be true. But I'm curious if you know any of the impacts of any recent hurricanes on any of these.
Yeah, so this is actually a whole other talk that I could give. That we have a National Park Service grant that was looking at the impact of Hurricane Michael specifically on a suite of sites in the in our area. And actually, while we were in the survey, Helene came screaming through the area and gave us a whole new thing to look at. And what was really interesting about that was we managed to have, we excavated two sites, J&J Hunt and Ontolo, which we're still going through all those data, and we'll be getting those ready here in the future. But we actually, in a really fortunate way, sediment cored and excavated both of those sites. And then a month later, Helene came through, and then we immediately went down as soon as it was safe and possible and re-cored the sites, because our excavation blocks were completely full. Like they were completely obliterated by the storm. You would have never have known we were there, which was incredible. And we were able to core that infill of our excavation block. So we actually got a signature of one Category 5 storm, which is kind of a unique little sneak in there. But I think in general, you know, the I shouldn't say that sites offshore aren't destroyed, right? Because it's a continuum. What I'm trying to say is that the prevailing theory is that they're all gone and there's nothing out there. But the reality is like, yeah, sure, some are gone for sure. No arguing there. And saltwater is more destructive. The coast is a high energy environment. But there's this definite continuum where some things get protected and other things don't. But it was really interesting to see the hurricanes, come through and do a number on those sites. We got to go back to a couple of the others. We went to Clint Scalapole, and there are still in situ flint napping station areas preserved there. Um, but obviously our blocks were filled in by 2 meters of sand in a single event. So, um, yeah, really, really interesting.
Awesome. Thank you.
Yeah,
We
you
have,
bet.
we have a question for Penelope asking if any of the charts you showed in the PowerPoint are available to view online.
Is there a specific chart you're referring to, Penelope? Most of them, I'll just go ahead and say, yes. The most of them are going to be in publications by myself on the topic of Ryan Harley and guest mammoth. And we're just getting really close to submitting the Quint Scalpel article. And then so these ones are published in Quaternary International. These are published in the supplementary materials for the Paige Ladson article, 2015 in Science Advances. Um, and these are all in a series of 2 articles about Ryan Harley in geoarchaeology and I forget the other one, but geoarchaeology and Paleoamerica. That's where they are. So and those are sole authored by me. So yeah, they're all and this one's also a Halligan, SOM.
Awesome. Thanks. And then we have another question from Shannon who said the acoustic echoing to locate submerged sites was so interesting to learn about. I'm curious what, if any, impacts the echoing has on marine life.
Yeah, that's a good question. So overall, the the frequency that we use is I'll just leave it here for now. The frequency that we use is something that is hearable in the human auditory spectrum. So it's 4 to 24 kilohertz. It is loud for marine life, but it's been deemed not to be a nuisance. We do get dolphin coming up to check us out all the time when we're running a chirp because they think it's a dolphin just saying the same thing over and over again, I guess. Um, but the traditionally acoustic methods like boomers and sparkers, which create massive amounts of sound, are damaging to marine life for sure. And I've been on boats when those are in use, and you have a marine wildlife spotter that's making sure that there's no animals in the area, and if they see one, you have to cease operations. But with these kind of higher frequency sound methods, there's really no adverse impacts.
Some thanks
And
for
yeah,
that. Yeah.
that's a really interesting area. It's way beyond me. I'm not a geophysicist. I'm just the person that the geophysicists tell to go get certain data sets, and then they look at them and tell me things that I rarely understand. But overall, it's just really fascinating. I mean, it's maybe this previously known capability of a relatively standard instrument that could, I mean, any way we can get an advantage out there is worth exploring for sure. I mean, clearly, what I should also say when I keep mentioning these 25, 26 sites we have out there, that number has pretty much stayed static for like I don't know, 15, 20 years. Most of those sites were found by Michael Fott and the Florida State University program in underwater archaeology in the 1990s. Of 26, probably 20 were found then. So in the last 20 years, we have 6 new sites, right? So clearly what we're doing is not working very well, at least. And most of those sites were found by target diving and side scan and looking at rock outcrops. Like that's how most of those sites were found. But trying to find a technological advantage, relying less on theory, because when you're trying to develop broad scale theories about behavior based on 25 sites, it's just a little bit of a problem of building a house on sand, right? So your foundation's not good. So if we can have some way of finding sites more reliably, then submerged cultural resource units can find them more rapidly during survey, avoid them more readily, and we can cut a lot of time and energy and frustration out of finding them offshore. Because with the modeling thing, if you take a landscape model and you identify where you think a site would be, then it's a quantum leap to proving that there's a site in the place that you think it should be, right? Because now it's one thing to have a dot on a map. It's another thing to put people on a boat, get them out in good weather, sink them right down on that GPS point, and then have them excavate and find material there. You can excavate at Page Ladson, there were 12 artifacts in component one. We excavated for years there without finding a single artifact, even though it's a site. So that's just if you can kind of bypass, all of that, I think the answer lies in the technology for sure, not in the theory.
Yeah, I find it very interesting. I was at a marine science conference, so not archaeology, but they were using similar technology and acoustics, setting up microphones all over the place to study spotted eagle ray diets because whatever they're crunching on has a completely unique sound. And so rather than catching them and then like making them vomit and studying their, stomach contents, they're using sound to figure out that they're eating conch in one area and something else in another
Yeah.
area. So it's just crazy, like you're saying, the technological advantage to study these unique coastal systems.
Yeah, I mean the Navy can identify the make and model of a submarine from, 3 oceans away, So this is pretty standard technology. The problem is we need students who are interested in pursuing these higher level questions, and adapting some of these novel technologies, to new questions.
All right, last chance, final call. Any last questions? All right, well, I think we can go ahead and call it a night. Morgan, thanks again. Excellent talk, very interesting stuff. Appreciate your time.
Thank you all very much. I really, it's a privilege to get to talk to other archaeologists. And yeah, thanks for reaching out and hope it was, hope it was informative. And I thanks for giving me an audience.
Absolutely. Have a good one.
All right.
It's great.
See you.
Thank you.